Hi everyone, I'll be introducing our experiment, the acid-base titration of pickle juice. We're using direct titration to find the concentration of acetic acid, the main acid in vinegar-based pickle juice. In this method, we add a solution of sodium hydroxide, which has a known concentration, to react with the acetic acid in the pickle juice. We also use phenolphthalein as an indicator. It stays colorless in acid but turns pink when the acid is completely neutralized. By measuring how much NaOH it takes to reach the pink endpoint, we can calculate the amount of acetic acid in the sample.
This objective is to determine the concentration of acetic acid in pickle juice using a direct titration method with a standard sodium hydroxide solution. This objective achieved by titrating the acidic pickle juice with a standard solution of sodium hydroxide that is a strong base. The amount of NaO required to neutralize the acetic acid is measured, and from this, the exact concentration of acetic acid in the sample can be calculated. Next, we will talk about theory and principle. Principle: stoichiometry neutralization. We have an equation CH3COOH plus NaO equal to CH3COO Na plus H2O. So, at the equivalent point, the number of moles of NaO added equals to the number of moles of acetic acid in the sample. By knowing the concentration and volume of NaO used, we can calculate the molar concentration of acetic acid in the pickle juice. For theory, acetic acid CH3COOH, a weak organic acid, is commonly found in vinegar and pickle juice. It can be quantified through an acid-base neutralization reaction using a strong base like sodium hydroxide. When titrated, acetic acid react with NaO in a 1:1 molar ratio to form sodium acetate and water. The titration technique involves gradually adding NaO of known concentration to the pickle juice sample until the acid is fully neutralized. This point is called the equivalent points and is detected by a color change of an indicator. Commonly phenolphthalein, which turns pink in basic condition.
Materials and chemical reagent. Apparatus and material that we use in this experiment, it is burette 50 ml, burette stand with clamp, conical flask, pickle 100 ml and 250 ml, measuring cylinder, funnel, pipette 25 ml, pipette filler, white tile, distilled water, dropper. The chemical reagent that we use in this experiment is pickle juice, sodium hydroxide solution standardized to 0.1 mole, phenolphthalein indicator, and distilled water.
Next, I will explain the procedure part. First and foremost, we have to standardize NaO. Why do we need to standardize NaO? It is to find the exact concentration of NaO using a pure, stable substance, which is KHP. KHP is the potassium hydrogen phthalate that has been dried completely and stored in a dry, airtight container. Hence why I will explain the procedure to standardize NaO first. What you need to standardize NaO? Standardized NaO is 0.1 molar NaO, potassium hydrogen phthalate, KHP, phenolphthalein, distilled water, burette, pipette, conical flask, and analytical balance. Next, the next step is, firstly, we have to weigh about 0.204 gram of dry KHP into a conical flask. Secondly, dissolve it in 25 to 50 ml of distilled water. Next, add 2 to 3 drops of phenolphthalein. It stays colorless at first. Fourth, fill burette with NaO. Fifthly, titrate KHP with NaO until the solution turns pale pink and stays for 30 seconds. The second last part is record volume of NaO used. And lastly, Repeat for 2 to 3 trials and calculate the average molarity using MaNOH equals to mole KHP over volume now in. After we're done standardizing the now, then we will move to the next procedure, which is to determine acetic acid in pickle juice by direct titration. Firstly, rinse the burette with now solution and fill it. Remove a bubble and record the initial volume. Next, use a pipette to transfer 25 ml of the pickle juice into a conical flask. After that, add 2 to 3 drops of phenolphthalein to the flask. Fourthly, titrate with now solution while swirling the flask continuously. Fifth, stop titration when a persistent pale pink color appears and stays for at least 30 seconds. Then record final burette volume and calculate the volume of now used. Lastly, repeat the titration until concordant readings plus minus 0.1 ml are obtained.
Now, let's move to the calculation. Step 1. Calculate the moles of now used. We begin by using the formula mole now equals to m times with V, where m is the molarity of now, which is 0.100 mole per liter, and V is the volume of now used, which is 0.02260 liter. So, mole now equals to 0.100 times with 0.02260 and equals to 2.26 times with 10 negative 3. Step 2. Use the mole ratio. We look at the balanced chemical equation between now and acetic acid. Now to acetic acid is 1:1. This means that the number of moles of acetic acid is the same as the number of moles of now used. So, mole acetic acid is 2.26 times with 10 negative 3. Step 3 is to calculate the concentration of acetic acid. We now use the formula C equals to mole over volume in liter. The volume of pickle juice is used 0.02500 liter. So, C equals to 2.26 times with 10 negative 3 over 0.02500 and equals to 0.0904 mole per liter. Lastly, convert to percent W per V, which is weight per volume. First, we convert mole per liter to grams per liter using the molar mass of acetic acid, which is 60.05 gram per mole. The calculation is 0.0904 times with 60.05 equals to 5.43 gram per liter. Now, to convert to percent W per V, grams per 100 ml, is by percent W per V equals to 5.43 over 100 and times with 100 and equals to 0.543%. The final conclusion are the acetic acid concentration in the pickle juice is approximately 0.543% in W per V.
For our conclusion, in this experiment, the concentration of acetic acid in pickle juice was successfully determined using the direct titration method with a standard sodium hydroxide solution. The titration process allowed for the identification of the equivalent point where the amount of now added was stoichiometrically equal to the acetic acid present. By applying the titration formula and using phenolphthalein as an indicator, the volume of now required to neutralize the acetic acid was measured, enabling calculation of the acetic acid concentration in the sample. The result obtained confirmed that titration is an effective and accurate technique for analyzing acidic component in food product like pickle juice. This method not only provides insight into the acidity level, which affect flavor and preservation, but also serve as a quality control measure in food processing. Proper titration technique and standardized solution were critical in ensuring the reliability and reproducibility of the result.